Okay, so quiz 2, it's going to cover sections 4.1, 4.2, 4.3, and 4.4. So here we have the f of x 3 to the 4th to the x power. And you can complete the table of coordinates by substituting -2, -1, 0, and 1, 2 into, or for the exponent. And so I'll just do that here. Oops, let me pick a different color. We have 3 to the 4th to the -2nd. That's a negative power makes the x, you have to do the reciprocal of the base. It becomes 4 over 3 squared. It becomes 4 squared, 3 squared, which is 16 over 9. My math lab wants you to use fractions. So for this one, I have 16 over 9. And then 3 to the 4th to -1 gives you 4 over 3. So this is 4 over 3. And then 3 to the 4th to the 0 power gives you 1. 3 to the 4th to the 1st power, just 3 to the 4th. And 3 to the 4th squared is 3 squared over 4 squared, which is 9 over 16. So you have these table of values, so -2, 16 ninths, -1, 4/3, 0, 1, 1, 3/4, and 2 9/16. Looks like it's going down. I'm looking at some of them. I think here we can eliminate D because none of the Y values are negative, and here you can see the Y values are negative. And I'm looking at to see. It looks like we can eliminate C because it's going up way too high here, above 4, so we eliminate that. So it's between A or B. Actually, let's also graph this using the graphing calculator, because if you have a graphing calculator, you can always double check. And so I move over to the graphing calculator screen. It was 3 to the 4th x. So we do 3 over 4 to the x power. And then you can get your table of values, although it gives it to you in decimal form. You can see what it looks like for the table. And then, oops, graph. I'm actually going to zoom in. And then you can see that you can see it closer to when you see it's at -2. You can see that it's close. It's very close to 2 because you have 16 over 9. And that -1, here's 0, here's that 1, and here's that 2. And it does look like that I chose the right one, B. Okay, so let's go back to main page. Okay, so go to next. Oh, it says I didn't complete it because I didn't type it in. Okay, so number 2. We're going to use transformations to graph f of x equals e to the x to graph the given function. And we have to also give equations of the asymptotes, use the graphs to determine each function's domain range. And then we can also use our calculator to confirm. So when there's an e and there's a negative next to the exponent, this is going to be reflected about the And so we're not doing vertically stretches or horizontal stretches. So you could ignore that. And if you have a negative in front of the exponent, it's going to be reflected about the y-axis. We click that, and then we can graph. And then you pick your exponent tool, and our base is E. We said it's going to be reflected on the y-axis. And then we also need to, let's see, graph the asymptote as a dashed line. So don't forget to do that. And so there's an asymptote at y equals 0, and then we're going to dash that and save. And the equation of this asymptote again is y equals 0. Make sure you type in y equals 0, not to 0. The domain of all of this function is negative infinity to infinity. Because the domain goes from left towards all the negative x values and right. And then the range goes from 0 to infinity. Okay, for this one, what's the equivalent exponential form? It's from logarithmic form. So you get the base, and then you raise it to the exponent, and then we set it equal to n. Just remember it's y, or I could also just do it as y equals log base b of n. Exponential form is by equals m. So you would type 9 to the 6 equals m here. And you're not solving, you're just rewriting it into exponential form. Or evaluate the expression without using a calculator. You could double check using a calculator, but here it's asking 9 to what power? Gives you 1 over 9. Well, we all know 9 to the 1 is 9. If I want a reciprocal of 9, I need this power to be negative. And so it's going to be 9 to the negative 1. So here, 9 to the negative 1. Or log base 9 of 1, 9 is negative 1. You could also check using your calculator. And I'll go over to my calculator right now. Okay, so get out of this and clear all this out. If you go to math and then log base, you could type in 9 and then 1 over 9. You get negative 1. If you're using a TI-83 and you don't have that log base button, you can use the change of base property and do log of 1/9 divided by log of 9. And that'll also give you negative 1. Okay, so here we're using transformations of the graph to graph f of x equals ln of x to graph this given function. And we also have to give the equation of the asymptote and determine the domain and range. If you have an ln, which is log base e, of a negative inside, that's also going to be a reflection about the y-axis. You might not get the same exact problem because it's, you might get a different looking problem. But when you have a negative, you have a y-axis reflection about the y-axis. Okay, so I have to grab the logarithmic graph and then just plot it there and reflect over the y-axis. We also have to draw the vertical asymptote as a dashed line. So I'm going to grab like my line tool. And then there's a vertical asymptote at x equals 0, dash that and save. So the vertical asymptote of that line is x equals 0. And the domain is, you can see how it goes from negative infinity for all the x values to 0. And then the range is negative because it goes down towards the negative y values and continues going up to the positive y values is negative infinity to infinity. And actually, it's negative infinity to infinity. The range is that for all logarithmic functions. Okay, we're going to use properties of logarithms. This is from section 4.3 to expand the log expression below as much as possible. And so here we're going to use the power rule, the product rule, and looks like the quotient rule. So first, let's separate each of these parts, right? So you have 3 of those parts there. So we can rewrite this as log base 9 of square root of a. And then it's going to be a product rule because there's a product here plus log base 9 of b to the 3rd. And then because it's quotient here, division becomes minus log base 9 of c to the 9th. I can rewrite square root of a as a to the 1/2. So let me rewrite that as an exponent. And now using the power rule, all of these exponents come in front of each of those logs. You have 1/2 log base 9 of a plus 3 log base 9 of b minus 9 log base 9 of c. So you would type that there. And when you type it, just be careful that you type it incorrectly with the 1/2. And then you can type log, and then the base 9, and then a plus 3 log base, and then 9 of b minus 9 log base 9 of c. Okay, for this one, we're going to condense the log expression, and the expressing, single logarithm whose coefficient is 0, and where possible, evaluate the log expression. So first, we can apply the power rule and put for 4 ln of x minus 2 ln of y, put the power back. And so this can be written as ln of x to the 4th minus ln of y to the 2nd power. And we're going to condense by using the quotient rule. This can be written as a single ln of x to the 4th over y squared. Okay, and so that would go in your answer box there. Be careful here that you make sure you put the ln in front of the parentheses. And so x to the 4th, and then you see how the ln goes in front of the whole parentheses there. Okay, so here it says use common logarithms to calculate or evaluate the following. Here we're using the change of base property, where if you have log base b of m, you can always calculate that as log m divided by log b. You could also do it with ln, log base b of m. You can also do ln m of n divided by ln of b. So if you have log base 13, 89.5, that can be written as log of 89.5 over log of 13. And so it says you're not to evaluate here. So here we're just typing in log of 89.5. And this whole thing is divided by log of 13. And now we're going to evaluate the expression using 4 decimal places. And now we're going to head over to our calculator. So here we got log 89.5 divided by log of 13. Rounding to 4 decimal places, it says, so it's 1.752. The 1 gets rounded up to a 2 because the 7 is bigger than 5. So we have 1.7522. Okay, for this one, we're going to solve the exponential equation by expressing each side as a power of the same base. And let me get my pen. So we have 2 to the 4 minus x. 1 over 8 can be written as 2 to the negative third, right? Because 2 to the third is 8. We know the reciprocal is going to be written as 2 to the negative third. So we have 2 to the negative third. So the bases are common. You have the common base, so you cancel that out. So we set the exponents equal to each other. 4 minus x equals -3. And subtract 4. And get negative x is equal to -7. And you divide both sides by -1. And you get x equals 7. The way you can check, so the solution set, I will put 7 there, is you can just plug it back in 7 into x and say 4 minus 7. Does that give you 1 over 8? Well, 2 to the negative third is equal to 1 over 8. And of course, you could check that using the calculator. Okay, let's go to the next one. Solving the exponential equation and express the solution in terms of natural logs or common logs. And then we're going to get the decimal approximation. So we have 10 to the x power is equal to 2.92. Because the base is 10, I'm going to use a common log. Common log is log base 10, where you don't write the 10 here. So log base 10 to the, oops, let me just write the problem down first. 10 to the x equals 2.92. I'm going to take the log of both sides, log of 10x, log of 2.92. And remember, if you do the power rule, it becomes x. But log base 10 or log 10 is just 1. Because this is 1, I don't need to write that down. So x is equal to log of 2.92. So that's what would go there, log of 2.92. And the solution set, then you would just type that into the calculator and type log. Let me just show that in the calculator. Log of 2.92. And I get 0.465 round to 2 decimal places, so 0.47. I will type in log of 2.92 there. Okay, for this one, again, solving the exponential equation, 2 to the x minus 1 equals 483. Whenever it's not a base 10, I like using ln or natural log. And so I'll do ln to both sides here. So ln of 2 to the x minus 1 equals ln of 483. Using the power rule, the x minus 1 comes in front of the ln. When it does, you have to make sure you put the x minus 1 in parentheses. So we have x minus 1 ln of 2 and equals ln of 43. This is held by multiplication, so I'm going to divide both sides by ln of 2. So we have x minus 1 equals ln 483 over ln of 2. And then we can add 1 to both sides to cancel. So there's the solution. X equals ln of 483 over ln of 2. And then we have to put the plus 1 on the outside. And then the solution set, just type it into the calculator. Shared the wrong screen there. Okay, so it's going to be ln of 483 over ln of 2 plus 1. So 9.92 will be our solution. Okay, here we're going to solve this log equation. We have ln of x equals 5. So here, to solve this, right, you have to rewrite it into its exponential form. So remember the implied base here, it's not written, but you have to know that the base is e. So if we rewrite it into exponential form, it becomes e to the 5th equals x. And so I would type that in here. You don't need to write equals x because you just want to type in the solution set. And then the decimal approximation, I would just put e to the 5th in the calculator. Oops. And round to 2 decimal places, so it's 148.41. Okay, solving this log equation, being sure to reject any values that's not in the domain. And so log base 3 of x plus 3 equals -4. We need to change it to exponential form first. And so the base is 3, the exponent is -4. So 3 to the -4 equals x plus 3. 3 to the -4, because it wants it in integers or fractions, 3 to the -4, I'll just do it on the side. It's the same thing as 1 over 3 to the 4th, which is 1 to the 4th, 3 to the 4th, that's 1 over 81. Or you can just type that into the calculator, and I'll show you how in a bit. So you have 1 over 81 equals x plus 3. And to solve for x, I'm just going to subtract 3 on both sides. And actually, I'm going to do that using a calculator now. So if we go to the calculator, so again, if you want to do 3 to the -4, you could type 3 to the -4. It gives it to you in fraction first, but you can go to math and change any decimal to a fraction. And because we had to subtract 3, and subtract 3 from that, it gives us -242 over 81. Okay, so going back to the main screen. So here I would write 3 to the -4 equals x plus 3. You're just rewriting the given equation in exponential form and then writing the solution set here, -242 over 81. Okay, let's see what 14 is. Solving the log equation Here, log base 2 of x plus 6 plus log base 2 of x plus 5 equals 1. And so we need to condense the logarithms first, because there's it's separated by a plus sign there. We can use a product rule. So we can rewrite this as log base 2. The product rule means we're going to multiply the x plus 6, x plus 5 equals 1. And let's rewrite to exponential form first. So the base is 2 raised to the exponent 1 equals x plus 6, x plus 5. Okay, we know 2 to the 1 is just 2. In the right-hand side, we can FOIL as x squared plus, if you do 6x plus 5x, that'll give you 11x, and the last terms will give you plus 30. Okay, now it becomes a quadratic equation. We solve quadratic equations by setting everything to 0. So 0 equals x squared plus 11x plus 28. So factoring now, what multiplies to 28 and adds to 11, it's going to be 7 and 4. So our factors are x plus 7 and x plus 4. So if we set both of these equal to 0, we subtract the 7 away, we get -7, and here we get -4. Now it says to reject any value of x that's not in the domain. What that means is logarithms have positive domains. You can't plug in negative values into the domain of logs. So if we plug in -7 here, log base 2 of -7 plus 6 plus log base 2 of -7 plus 5. Here you get log base 2 of -1 plus log base 2 of -2. You can't take logarithms of negative values. It just doesn't work. So I know -7 is not going to work. So let's check -4. So if we plug in -4, you get +2 and +1. And although the x value was negative, after you plug into the domain, it becomes a positive number. So the only solution to this would be x equals -4. Actually, okay, let me just type one in. We need to rewrite the equation without logarithms. It says do not solve for x. So I would rewrite this as 2. Where's the exponent button? 1 was x plus 5. And then the solution set here is only -4. Okay, so this is the last one, 15, solving the logarithmic equation. And so here we got 2 log base x minus log 5 equals log of 20. And so we need to rewrite it and condense it first. So here the 2, we can put it back into using the power rule. So we have log base x squared minus log of 5 equals log of 20. We're going to condense the left-hand side using the quotient rule and rewrite this as log x squared over 5 log of 20. When you have logs on both sides, you can cancel, and that's the only time you can cancel if you have a single log on the left, a single log on the right. So now we have x squared over 5 equals 20. So let's multiply both sides by 5 to cancel this 5 in the denominator. You get x squared equals 100. Taking the square root, you get x is equal to plus or minus 10. Now we're going to reject the -10 because if you plug -10 here, you get log of a negative number. So the only solution is 10. And so here, we're going to rewrite this equation without the logarithm. So you would type it in x squared over 5 equals 20, oops. And then the solution set would be positive 10.